So we're back in the TypeScript edition of the MiniCraft rewrite, working on this Electron game engine, and I got the level generator ported over. I wanted to talk to you about how I got this thing done. But if you load this up now, you'll see that like the level gen button is there, and you hit the regen button to regenerate the map as needed. You can go up into the sky level, and you can go down all the way into the caverns to the very bottom, depth 3, it's all lava. And I want to talk to you about the steps I took to make this happen. So, the main menu scene, all these buttons are the same well, they're all at x equals 10. Over at the left side of the screen, starting at the top at y equals 10. For each button, just add 10 to it here. But it made it really easy for me to insert a level button right there in the middle. Click on the level button, and you see that it enters the level generator scene here. The level generator scene extends from the scene object, the scene class, and set the width and height at the top. Those get passed into the level gen class. We initialize it with the top map. Depth is 0. But got a similar thing here. We put the buttons here, the right side of the screen, and we have buttons for to regenerate the level, called regen level if you click it, and then up and down, both either subtract or add to the depth, clamp it to the ends of -1 to 3, and then call regen level to regenerate, and then the back button will exit the scene. And the label button, I don't know, kind of like this is like cheap data binding here, but by passing in a function that returns an interpolated string, we're able to render the current value of the depth variable on each frame. And 0, 0 puts it in the top left corner of the screen. And you can see regen level calls this function down here, and then depending on your current depth, it will choose which of the levels to generate. Each of these create and validate functions will return a two-dimensional array. The first index is the map, the second index is the metadata for the map. We only need the tile ID, so we're grabbing index 0. And then when we render, loop over the entire map. For each tile, we choose what color to draw. If it's water, you can see it's red and green are 0, blue is at hexadecimal 80. All the ores are drawn in yellow. If there's an unknown tile ID, then we spit it out to the console so we can log it and account for it later. And got some keyboard handlers and mouse handlers down here. These, don't really need those. Clip those out. But if you hit escape, it'll exit the scene, just like if you hit the back button. The level gen, it depends a lot on the tile factory, which I don't have. So instead I created an enum with all the tile IDs we need in order to generate a level. We'll come back through and do something nicer with this later. When you construct a level gen class, what it generates is basically, it looks like a Perlin noise map. Width, height, and feature size. I thought Perlin noise has a couple more variables going in, so I think there might be something else going on here, but I'm not really sure. We initialize a 2D array of random values going from -1 to 1, and then we step over that map in smaller increments on each loop and do a bunch of math sampling the map and averaging things together. Kind of makes a smooth noise map. And we have 3 validators: create and validate top map, underground map, and sky map. purpose of the validators is to create the map and then count how many of each tile type is available and make sure that a certain number of each tile type is there. Like if you didn't have enough rocks, you wouldn't be able to make the tools to go to the next level. Didn't have enough trees, it's like same problem. And you can see that's the same thing, the underground map, make sure you have a certain amount of ore. Make sure you have stairs. The sky map, make sure there's enough clouds. In the create top map, each of these, like create top map, create sky map, create underground map, first thing it does, it uses the height map data from these noise maps to determine what should be placed. If it's less than -0.5, it's at place water. Greater than 0.5, it'll place rock if this inval condition is satisfied, and otherwise it places grass. Just think of inval as magic, I don't know, magic noise values. It helps make sure that it's not all rock over that value. And we got some loops here. This one will place patches of desert. It picks a random spot on the map and then picks random spots around that position, and then we'll place a bunch of 3x3 squares of sand. It makes it look like a desert. Got similar things going on here to place trees and flowers on the grass, and to place cactus on the sand. And then this will look for a 3x3 grid of rock and place the stairs in the middle. I don't really like using these labels, but the original code in Java did this and TypeScript supports it. I'll probably come through to rewrite this later. The underground map does something similar. There's a lot more of these noise values. But it's basically the same type of thing. If the depth is greater than 2, then it'll place lava instead of water. And you'll see here, if you have each of the ore IDs need to be in sequence for this to work. Like the ore ID +1 is gold, +2 is gem. So if you add more ores, make sure they're all right next to each other in the map. I'm going to try to make this a little more robust later. And yeah, sky map is either clouds or you fall to your death. And that is basically it for how this thing works. Performance is pretty good. Next up for this edition of the MiniCraft rewrite is the level, actually rendering the level. We're going to need a better tile factory. And hope you can join me next time. Thanks for watching.